Hi, good morning, everybody. I hope you had a great holiday and you're rested and ready to do your last lab. So this one is definitely a long one. So when you are doing this lab, don't wait until the last minute. And just remember that it's a marathon, not a sprint, right? So it's divided up into sections. So maybe at the end of each section, go get a snack, go outside. You could do maybe a section per day. I've made it so that you can come back and reopen the submitted form. So you can submit like a halfway done one and then edit it. But before committing wholly to that, just make sure that it actually works. So like maybe fill out the first one, submit it, and then see if you can edit it before making that your plan. Because I think that I did that, but honestly, technology these days, it's past me. So for this lab, I just want to go over a few things. I'm not going to have a PowerPoint that like sometimes because this lab is long enough. It's pretty self-guiding, but I just want to make sure that we hit on a few points, and then I'll let you loose. So I'm going to go ahead and share my screen so we can all look together at the lab. Okay, so our last lab is exercise 8. If you've been following along as I suggested, if not, whatever lab you're doing this week should be your last lab. And in that case, you're lucky because there's already lectures that are up. And so you can get started on it straight away. But if you're doing exercise 8, it's climate change. Again, this is our last lab. Next week, there will be an extra lab up. It's a paleobathymetry lab. And it's sort of a culmination of everything we've learned in this class. So it's great to do, 1, if you need an extra lab for points, 2, if you need extra credit or want extra credit, and 3, even if you don't need or want any of those first 2 things, it's a really good study guide for the final. Again, because it's all inclusive, it's taking things that you've learned in each lab and putting them together, which is what we want to do in this class, right? It's a building learning experience. It's not just one day you learn something and the next day you learn the next, and they never relate to each other. All of the labs in this class relate to each other. So hopefully you have seen that. If not, the extra lab, the paleobathymetry lab, will show you that. And that'll be right down here underneath exercise 8. It'll say, I think it's exercise 11, paleobathymetry. But that's for next week. For this week, we're doing climate change. So the main difference between when people say climate change, and then they'll say that it's global warming, and then we have like the coldest winter in Boone for the past 10 years or something like that. People will say, climate change isn't real. But there's a difference between climate and weather, right? Or there will be a nice day in April and a nice day in January, and people will say climate change isn't real. Weather is from place to place, right? So living in Boone, we know that we sort of live in a little mini mountain weather phenomenon place where it can be 50 degrees or 30 degrees in the morning and 70 degrees by the afternoon. Or if it's raining or super foggy up here, maybe in Wilkes-Barre, it's a super beautiful day, right? So that's weather, place to place. It's different from one location to the next. In the mountains, it can be different from 5 miles away. It can be different from 10 miles away. In places where you've got flatter terrain, usually those weather patterns are a little bit more expansive, right? So it might be different 100 miles away or 200 miles away. And the main reason for that is our mountains, right? So our mountains create these little mini climates that give us a sort of weird weather patterns. So rain clouds stall over mountains a lot. So if you look at, for example, Nevada in California, they've got 2 big mountain ranges, the White Mountains that run on the border of Nevada and California, and then there's a valley, and then there's the Sierra Nevada mountains, which is another huge mountain range. Both of those mountain ranges have mountains over 14,000 feet in them. And so on one side of that mountain range, there's a big desert, the Death Valley, right, which is one of the driest places in the U.S. Is, definitely, and also in the world. And one of the reasons why it's so dry is because rain coming from the ocean, coming from the Pacific, has to pass through two major mountain ranges. So if you imagine a rain cloud coming from west to east, from the Pacific over land, first it hits the Sierra Nevada, it dumps a whole bunch of rain. That cooler mountain air causes a pressure change, so it dumps all that rain on the Sierra Nevada. And then we've got Owens Valley, which is a little arid, but still is a pretty good source of water. It's LA's water basin. And then that cloud keeps moving by or through, and then it hits the White Mountains, and whatever water it had left, it's dumping there, right? And so right on the other side of the White Mountains is a huge desert. And so that desert is caused because of those two huge mountain ranges right to the west of it. So mountains are a place where you've got a lot of change and weather happening super often. But if you're out in the plains somewhere, out in the greater continent where it's relatively flat, those weather patterns can move on through without relatively any disruptions. So that has its drawbacks as well, right? There's a lot of tornadoes out there. There are huge thunderstorms out in the plains because those clouds, that weather pattern or wind is building, right? It's almost like if you think about waves and how they build, right? They need a long fetch, a long distance where the wind can blow. And that same sort of thing is happening in the plains. If you've got a long distance where wind can blow uninterrupted, you're gonna get some crazy storms. And super expansive storms. So anyways, that's weather. And then climate is sort of over the greater area, so the southeast in general, or mountain belts in general. And they last a longer time span. It's not day to day or even really month to month, it's years to years. So when we talk about climate change, we're talking about an overall change of seasonal weather, yeah, but also just an overall change in climate, an overall change in, you probably have heard the phrase like a Mediterranean climate. Well, what does that really mean? Does that mean that it's arid and nice every single day? No, it just means overall, that's usually what you're getting. So climate change is a totally natural process, right? So it's very cyclic. It goes up and down, warm periods, cold periods, and it's very, very natural. There's things like wind patterns on Earth that affect it. The tilt of the Earth affects climate change. How close we are to the sun from year to year affects climate change. And it's super cyclic and very natural. The thing that's not so natural is when humans get involved and create an excess of carbon dioxide and carbon monoxide in the air, and it starts to heat up things. And so the repercussions is what we're dealing with now. Larger storms, bigger hurricanes, mass extinction events that are not natural, right? We also are getting climate refugees, right? So climate refugees are people who are fleeing from an area that is no longer hospitable. So be it floods or a sudden change in rain amounts. So maybe you were getting a temperate amount and now all of a sudden it's semi-arid and none of the crops that used to grow there grow. Maybe it's that you used to fish this certain type of fish and now the water is too warm for that fish and they've moved north. Right, so people are moving because of these conditions. You see it as,
oh, puppy! Hi, Mama. Okay, you gotta get out of here. I'm teaching. You gotta go. Hi.
Sorry, puppy break. So you can. What was I just talking about? Climate refugees. So we see it in Boone as well. Not to a huge. Not to a huge extent, but we do see people coming here all the time buying second homes, right? And those people buying second homes want a nice, summer or winter home to go to, right? So you don't see, usually people buying second homes in a place that's not nice weather-wise to live in. So Boone is a place for climate refugees. We see people moving from the coastal plains to Boone to escape rising sea levels and hotter conditions.
Hi, Lena, I'm so happy to see you. Hi.
So when you're talking about climate or weather change to, your grandpa or your grandma, and they're talking about how climate change isn't real, you can hit them with all these facts that it absolutely is real. Or in my case, if you're talking to your parents about it. So that's the difference. That's the main difference between weather and climate, right? And we want to be sure that when we're talking about weather or we're talking about climate, we're thinking about those two main differences. So the next thing I just want to scoop down. This is all, well, let's talk about this too. So this graph in particular is climate change through historical time. And so when we're talking about historical time, we're talking about something that has been documented and something that is within human times, right? So when we talk about geologic time, we talk about deep time, where 1 million years is a short amount of time, right? But when we talk about climate change, we can talk about it in historical time, and that's over the last 1,000 years. So you'll notice even within that time, it's pretty cyclic, right? There are ups and downs, ups and downs, ups and downs, ups and downs. And then you notice this right here, this huge up. And so notice the time, it's about the 1820s, and that was during the Industrial Revolution, right? We were burning a ton of coal. All of that carbon got released into the atmosphere, and all of a sudden, we saw this huge increase in global climate temperatures. And so all of this is what we call anthropogenic. And there's even this big debate in the geology world over whether or not this should be a new era or a new time period. So if you didn't know, right now we're in the Pleistocene, and people, scientists have argued over whether or not we should make this, starting right here at the Industrial Revolution, the Anthropocene. I think no, because we're tiny and small in the grand scheme of things, and we're going to kill ourselves off with climate change. So why name a whole era after us? But other people disagree. So I guess it just depends on how morbid you are. So this is this big climate change debacle that we've sort of gotten ourselves into. And so when people talk about climate change being a bad thing, this is what we mean. But climate change is very natural when it happens in a natural timeline. This is not quite natural, right? Speaking about things that affect climate change, one of the big things is El Nino. Well, I skipped ahead, but that's okay, is El Nino. And so El Nino is a really cool phenomenon. And I'm gonna do a new share so I can show you what I mean by that. So this figure is from the Earth Observatory and the NASA website. So if you wanna know more, if you're super pumped about El Nino, you should come to this website. But this is what's happening usually. In the Pacific, especially, it's such a large expanse of water. We get a lot of evaporation and then precipitation, right? So all of this is evaporating up. These are sort of your evaporating clouds. And then they travel in the wind column, and then they precipitate down. And then the same sort of thing happens. We've got evaporation, precipitation. The same thing happens in the Atlantic, just not to a large degree, because the Atlantic isn't as big of a body of water as the Pacific is. And so this is in normal conditions, what's going on. We've got sort of east-west circulation. And then in El Nino conditions, we get the opposite. So we start to see evaporation closer to the continent. We see warmer waters. And so warmer waters means more evaporation. So with this warmer water, we get evaporation closer to the continent. And that means that areas that don't usually get a ton of rainfall, a relative amount of a ton of rainfall, are getting dumped on, right? So Japan, south of Japan and east of China are getting totally dumped on, and areas that rely on that rain are not. Like what is this? Is that the, oh man, Black Sea, maybe? Could be the Caspian. I don't know. It's a sea over in Eastern Europe, that usually is getting a ton of rain with an El Nino conditions is becoming a more arid environment. So in El Nino conditions, it becomes super arid here, crops die, and it's super rainy over here, crops also die, right? Or there's a lot of flooding. Same deal over here. Here where water is usually evaporating, instead water is being precipitated. So again, a lot of flooding, a lot of storms, unusual conditions, but this is a natural phenomenon. So we learned about how winds really impact waves. Wind also impacts climate, right? So remember from the currents and the tides, wind is really impacting not only waves, not only current circulation, but also weather, right? Of course. So with weakening trade winds, this allows for warm water to sort of creep up to where it previously hasn't been allowed to get to because of trade winds fighting it. And then that warm water causes all of this difference in precipitation and evaporation. Have you guys seen the movie Day After Tomorrow? With, I think is it Dennis Quaid maybe, and also the guy, is it Jake Gyllenhaal? I can't remember. Have you guys ever seen that movie? Do you know what I'm talking about? It's a great movie. Well, so if you haven't seen that movie, you should watch it because I think it's the best geologic movie that actually has like real science. It just happens in a 1 to 2 day time scale, where in reality it's going to happen in 1,000, maybe 500 years if we really screw things up. Year time scale, but the science is totally correct. What happens is that influx of cold water from melting ice caps shuts down the current and creates places that were originally or normally okay to live in, hospitable for humans, to be a total disaster, to be completely freezing. So if we think about where, let's just go ahead and pop open Google Earth, my favorite thing to do. If we think about where England is, or where Norway and Finland are, the same with northern Canada, where people live and work, it's really, really far north, right? Like that's England. That's incredibly far north. But the reason why people can wear shorts and shirts, t-shirts out, and that it gets 100 degrees Fahrenheit here is because of circulating weather patterns and also currents, right? So if we keep increasing the global temperature, what happens is that our ice caps will melt and influx a lot of cold water, and that cold water is going to mess with this current that's traveling through here. And so if you mess with this current, you also mess with the hospitableness, the ability to live in these places. So, I mean, notice Spain as well, right? That's not exactly, whenever I think of Spain, I always think like almost near the equator. It's nowhere near the equator. It's on par with New Brunswick or Nova Scotia in Canada. But I'm sure when you think about Canada, you think about cold temperatures. And when you think about Spain, you think about nice Mediterranean arid temperatures, right? So the reason why these are different is because of our currents and because of our weather patterns. So when things mess with the weather patterns, we start to get this abnormal, quote unquote, abnormal temperatures and overall climate change. So with this lab, I ask you to go to a few websites that I wouldn't ask you to go to if I didn't think that they were cool. So the first one is this NOAA Tides and Currents website, and you click on this and it'll take you here. And to get to this spot, you go to, so actually let's just take it from the beginning, why don't we? You go to NOAA Tides and Currents. Oh wait, you can't see my screen, can you? That's good because I accidentally just flashed some grades and I just was gonna roll on by. So right here in your lab, you are gonna go to the NOAA Tides and Currents. and you go to what do we do, or what we do, and head to here. This is all outlined in the lab, by the way. I just want to take you there myself. And then you're going to go to sea level trends online. And so this is just going to show you overall sea level trends. So we can see already sea level is rising. This is what I talk when I'm talking about, you know, climate refugees in Boone. Slowly, inch by inch, millimeter by millimeter, the land here is, you know, going underwater. And so people are moving inland, and we are inland and also in a really beautiful place. There are some places for sure where sea level is dropping, but that's not a good thing, right? Up here, there are sea communities that really rely on being close to the ocean, close to the ports. And every year they're getting farther and farther away, right? So either they need to pick up their villages and move, or there needs to be a change in profession, right? And so also as they're getting farther and farther away from the ocean, they're getting farther and farther from those weather patterns. And so therefore, in this instance, getting colder and colder temperatures. Another cool website that I'm going to ask you to go to, or I think is cool, so therefore I'm making it your problem as well, is going to the Global Flood Map website. And so some snacks. And so if you click on here, this is going to take you to an interactive map where you can, so the blue is below sea level, the dark green is high ground. And you can put in here, like, what would happen if you raise sea level by 100 inches, how that's going to affect the mainland, basically. And it also lets you know, like, the number of people that would be sort of flooded out of their homes, which is a staggering amount. So let's go crazy and do like 2,500 inches. Whoa. Pretty insane. And then you can also like scroll in and see exactly what that means. I mean, that's all of the coastal plain underwater. Florida's gone, which probably nobody cares about anyways, but but we don't know. My partner just said, hey. Here's in the Mississippi River Delta. See, all of this would also be underwater. Right, so it's not just what we think of the coast. It's also far into the inlands, depending on big river deltas as well. So I ask you to play around with that as well. Alrighty, so that's your job for this week. To do this lab again, I would caution you to take time to do this for sure. It's going to take a little bit. If you can, do it in sections, right? Knock out a section in 20 minutes, submit it, put it on pause, and then start working on it again. I'm pretty sure if you just leave the tab open, you should be okay, but you guys would know better than I do. If you do try out that thing where you submit it and then, you know, reopen it to work on it again, make sure that you test it out with like one question. So for example, if you go to the answer sheet, maybe like just do your name, submit it. Oh, I guess you can't submit it because these are, because those are required. So I'll try and find out if I can make it so that like things are saved and you can go back to it. But if not, you should just be able to leave this open for the week. Just don't accidentally close it, I guess. But again, you guys would know more about that than I do. And that's it. Good luck. Let me know if you have any questions. As always, office hours Tuesday and Wednesday. If you can't meet at those times, just let me know. I'm happy to meet at another time. And look out for the extra credit / extra lab / study guide that will be next week. Okay.